We're on problem 129. On a recent trip, Cindy drove her car 290 miles, rounded to the nearest 10 miles, all right, and used 12 gallons of gasoline rounded to the nearest gallon, so 12 gallons. The actual number of miles per gallon that Cindy's car got on this trip must have been between. Okay, so they want us to kind of say, okay, these are the rounded numbers. Now, what were the actual numbers between? And then from that, what's the range of miles per gallon? So if this is the rounded to the nearest 10, then her miles had to have been greater than or equal to 285, right? Because anything 285 or more would have been rounded to 290, but then less than 295. Right? Because anything less than 295 would be rounded down, but 295 itself would be rounded up to 300. Fair enough. And her gallons had to have been greater than or equal to 11.5 gallons by the same logic, and less than 12.5 gallons. Fair enough. So what was the lowest possible miles per gallon? So the lowest possible miles per gallon would have the lowest miles and the highest gallons, right? You want to minimize the numerator and maximize the denominator. So the lowest possible miles would be 285, and the highest possible gallons, at least it'll approach 12.5. It'll approach 12.5. So this is, 12.49999 is a possible number of gallons. So it'll approach this. But it can never be exactly 12.5 gallons. So her miles per gallon are going to be greater than this. It would have been greater than equal to this was like 12.4999999. But since 12.5 we can never get there, we're going to be greater than this in terms of miles per gallon. And then the highest possible miles per gallon is the highest possible miles, which is 295. But we're never going to be able to go quite there, right? We're always going to be less than 295. And then the lowest number of gallons, right? Going the highest mileage with the lowest possible gallons. You want to minimize the denominator. Divided by 11.5. Let's see if that is a choice. So they say, let's see, I don't see that exactly, but choice D looks interesting because choice D says, so they say the actual number of miles per gallon that Cindy's car got on this trip must have been between. Choice D looks close to what we have, right? Because we have this. Choice D says between 284 divided by 12.5. So 284 divided by 12.5. That's going to be even less than that, right? Because you have the 12.5, but the numerator is less. So that's going to be even lower than the range that we have. And then on choice D, 295 divided by 11.4. 295 divided by 11.4. This number is larger than this number because you have the same numerator and you have a smaller denominator. So you're dividing by a smaller number. So this number is larger. So if her miles per gallon is between these two numbers, and these two numbers are between these two numbers, then yeah, D is right. Her miles per gallon need to be between 284 divided by 12.5 and 295 divided by 11.4. So it's choice D. Problem 130. 130. Which of the following inequalities is an algebraic expression for the shaded part of the number line above? Okay, so this number line, let's try to draw it. That's the line. And I'm not going to draw all of the dots on it, but it essentially starts at positive 3 and it goes backwards. Switch colors. It goes positive 3. Well, not all, no. It's essentially from minus 5 to positive 3. That's all of what this includes. This includes minus 5 to positive 3, and then you have, 2, 1, 0, and then minus 5. So you could say that x is less than or equal to 3, because it's filled in at 3, and greater than or equal to minus 5. And that's not one of the choices. They want it in terms of absolute value, right? So they want absolute value. So what we can view this is a range around some number. Whenever you're dealing with absolute value, you're essentially saying the distance from some number. So this is a range, let's see, minus 5 and 3. This has a length of 8. So they're both 4 away from minus 1, right? Think about it. You could go 4 backwards or 4 forwards, right? So one way to think about it is the difference between x and minus 1, the difference between x and minus 1, and that might be a negative or a positive difference depending on whether we're positive or negative. But we just want the absolute, depending on whether we're above negative 1 or below negative 1. But we just want the absolute difference, right? We just want the distance away from negative 1. So the distance away from negative 1, and that's given by this, right? The difference between any x and negative 1, and we took the absolute value in case x is less than negative 1. The distance is going to be less than or equal to 4, right? Because if we go above negative 1, we're at most at 3, which is 4 more than negative 1. And if we go below negative 1, we're at minus 5, which is 4 less than negative 1. So it's less than or equal to 4. So if you simplify this, you get x plus 1, the absolute value, is less than or equal to 4. And that is choice E. And this is a useful skill. I don't know, you're probably taking the SAT already, but in general, a lot of standardized tests think of absolute value as a distance in one dimension, right? So distance along the number line. So you're saying, oh, well, all of these points, there's some within some range from 1 point. And you could say, oh, if you take the midpoint of this, you're at negative 1. And every point here is within 4 of negative 1. So the distance between every point on this line, every x that satisfies this, and negative 1, the distance is less than or equal to 4. Anyway, I kind of just did the problem twice for you. Problem 131. 131. A factory has 500 workers. 500 workers, 15% of whom are women. So 15% times 500 is equal to women. If 50 additional workers are to be hired and all of the present workers remain, how many of the additional workers must be women in order to raise the percent of women employees to 20%? Okay, so how many women workers do we have right now? 5 times 15, we have 75 workers, right? 15 times 500. Yep, 5 times, 75. Right. We have 75 women right now. So right now, 75, if we wanted to find the proportion of women, it's 75 over 500, which is, once again, it's 15. It's 15%. And let's see, we're going to add a total of 50 workers to this population. And they want to know how many of the additional workers must be women in order to raise the percent of women populations to 20%. So we're adding 50 total workers, and then so how many of those have to be women in order for the new proportion, right? This is going to be the new number of women, the number of women that are added to the 75 that were already there, divided by the 500 workers who are there plus the 50 new, some of whom might be women. So this now has to equal 20%. So let's see, we get 75 plus W, that's a W, over 550 is equal to 0.2. So we get 75 plus the number of women that need to be added is equal to, let's see, 0.2 times 550. We multiply both sides times 550. That equals 110. Right? Yep, 110. 110. Right. 110. And then, so subtract 75 from both sides. Women, it has to be equal to 110 minus 75. And that's equal to, let's see, 25 plus 10, that's equal to 35. 35 of the 50 women, 35 of the 50 employees have to be women. And that's what they ask, right? How many of the additional workers must be women? So that's choice E. Next question, 132. 132. In a small snack shop, the average arithmetic mean revenue was $400 per day over a 10-day period. So the average over 10 days was $400. During this period, if the average daily revenue was $360 for the first 6 days, so the average of 6 days was $360, what was the average daily revenue for the last 4 days? So we've done a lot of problems like this. Hopefully this is a bit of second nature if you've watched the solution to the other ones. But what's the average of all of them? Well, it's the average of the first 6 days, right? So the average of the first 6 days, we could almost assume that the first 6 days had exactly $360 in revenue. So it's their average times 6. So this would be the total revenue of the first 6 days, plus what's the total revenue of the next 4 days? What's going to be the average of the next 4 days times 4, right? That would be the total of those 4. We're not saying that they all have to be exactly the average, but when you sum them all up, they're equal to the average divided the average times 4. Now, if you divide all of those, this is the total of the revenue of all 10 days. If you take that sum and divide it by 10, you get the average for the 10 days. And that is equal to 400. Now, let's simplify this a little bit. Let's see what we could do. Well, we get, let's see if we could, so we get 360 times 6 plus let's just say well, I'll call it the average for 4 days times 4 is equal to 10 times 400, which is 4,000. Let's see, before I get too involved in multiplication, let's divide both sides of this equation by 4. So 360 divided by 4, that's 90 times 6, plus this divided by 4, plus A4 is equal to 1,000. 90 times 6 is 540, plus the average of the 4 days is equal to 1,000. So the average of the 4 days is equal to 1,000 minus 540, which is what? That's $460. Is equal to $460 per day. And that's choice D. And I'm out of time. See you in the next video.